This podcast is about the types of reactions that happen in chemistry. So there are 5 basic types of chemical reactions, and those include synthesis, decomposition, single replacement and double replacement, and combustion. And a couple of these have other names that they go by also, but these are the ones that we are going to use. A synthesis reaction is where 2 reactants come together and make a single product, one product. So a general equation is A plus B goes to form product C. If we're going to predict what the products are going to be for synthesis, if they're ionic, we can predict them because we know rules to predict what compounds, formulas are going to be made in ionic compounds, so we can predict the products. If they're covalent, because they can make lots of different ratios, we're not going to predict products in this case. So here's some examples of synthesis reactions. If you've got 2 elements coming together, they're going to make a compound. If it's ionic, then we can predict it. Aluminum chloride in this case, 1 aluminum, 3 chlorides. After the formula is finished, then balance it by adding coefficients. Don't forget that chlorine is diatomic, so you have to remember those. The next one, lithium, which is a metal, and sulfur form lithium sulfide, which has this formula. And again, it's balanced by then adding the 2 for lithium here. If the reaction has a single product, we say that it has to be formed by synthesis of the elements that it's made from. So in this case, nitrogen plus oxygen come together to make dinitrogen tetroxide, and then the 2 is added to balance the O2. You have to remember again the diatomics, and then antimony plus chlorine makes antimony trichloride, and again we later go back and balance with coefficients. The decomposition is exactly the opposite of synthesis. It's where a single reactant, one reactant, falls apart and it makes 2 or more products. So it's pretty easy to recognize because it always has a single reactant over here on the left, and then typically 2, sometimes more products. So one example is hydrogen peroxide, which falls apart and makes its 2 elements, hydrogen and oxygen. If it's binary, which means it has just 2 elements, for example, hydrogen peroxide up here has 2 elements, hydrogen plus oxygen. If it's binary, then we say that it's going to decompose to make its elements. If it's not binary, if it's more complicated, we don't usually predict those except in the case of carbonates. So if we have something that has a carbonate, or CO3, then it's going to fall apart and make CO2, and we'll see an example of that. So here's some examples of decomposition reactions. Binary KBr is going to fall apart and make its 2 elements. Don't forget the diatomics. And again, the one we already saw, hydrogen peroxide, makes hydrogen and oxygen. If it is a carbonate, and carbonate, remember, is CO3 with a -2, like calcium carbonate here, it's going to lose CO2. So you're going to pull CO2 out, and then whatever is left over is going to make the rest of the products. Aluminum chloride is binary. It's going to form aluminum and chlorine, which is diatomic. And then don't forget to balance when you're done with the formulas. The next reaction type is single replacement, and that's where a single element reacts with a compound. That's how we know it's single replacement, 1 element plus a compound. And it happens because some elements are more active, which means they want to bond more than other elements. The general equation is you start out with an element all by itself plus a compound, and the element, typically a metal, comes in and kicks out the other metal and makes a bond with C. So we've got AC, and then B, which has gotten kicked out, is now by itself. Here's an example. Magnesium, which is our metal element all by itself, reacts with silver nitrate. So magnesium is going to come in, kick out silver, make a bond with nitrate to make magnesium nitrate. And notice because magnesium is +2, it does change the formula a little bit, the pattern. So we do have to make the formulas correct because magnesium with nitrate has a different number of nitrates than silver with nitrate. Don't try to balance by making your formulas match because they don't always match. And now silver is all by itself. Then we go back and add the coefficients, add the 2 here, add the 2 on silver to make the reaction balance after we're done with the formulas. So the products of a single replacement, if we have the element as a metal, then the metal is, which can be hydrogen or a metal, is going to replace the metal or hydrogen. So you're always going to replace the atom that is like the element. If it's a nonmetal, typically a halogen, then the halogen is going to come in and replace the other nonmetal, again, typically a halogen. And we'll show an example of that. Okay, so in these examples, lithium, which is a metal, comes in and kicks out copper, the other metal, and makes lithium sulfate, and copper is by itself. Bromine is a halogen, it's a nonmetal, and it's going to kick out the other nonmetal, which in this case is chlorine. So bromine comes in, kicks out chlorine, makes a bond with sodium, and then chlorine is all alone. Zinc kicks out silver and makes zinc nitrate and silver metal. And aluminum is a metal. It's going to kick out hydrogen because hydrogen acts like a metal to make aluminum chloride, and then hydrogen is the element left over, and that's H2. Don't forget to balance, but not till you're finished making the formulas. So now we get a little bit more complicated because we have to be able to determine if these reactions are going to happen. And to do that, we're going to use something called the activity series, or the activity series of metals, or metals with hydrogen. And that's shown on the next page. On the right is the activity series that we are going to use. And it's written so that the highest activity metals are at the top, and then the lowest activity metals are at the bottom. So this is the ranking of the activity series of metals. And in the lab that you did, you could see how you could use reactions to figure out which metals are the most active and the least active and in the middle. And the way this works is when you do a single replacement reactions, the two metals sort of compete with each other. And the one that's higher in the activity series is the one that's going to make a bond. So I'm going to do 2 examples here, and the key to the rest of these is on Schoology. So you'll need to do them and then check your work. So zinc and hydrogen chloride, which is also hydrochloric acid, react with each other. Zinc plus HCl. So you have to look up zinc in the activity series and hydrogen. So let's see. Zinc is up here and hydrogen is down here. So zinc is higher and hydrogen is lower, which means hydrogen would rather be alone and zinc would rather bond than hydrogen. So they are going to react because zinc is going to kick out hydrogen because zinc is higher activity and it would rather make a bond. Hydrogen is lower activity, it would rather be alone. So this reaction is going to happen. The other example I'm going to use is number 4, which is silver plus sodium hydroxide. Silver metal plus NaOH. So you find silver and you find sodium on the activity series. Sodium is up here and silver is all the way down near the bottom, which means silver is very low activity, it would rather be alone. Sodium is higher activity, it would rather bond. So when silver reacts with sodium hydroxide, there's no reaction that's going to happen because silver is less active. It doesn't want to bond compared to sodium. So no reaction is going to happen in this case. So for the rest of these, go through, find all the metals and hydrogen on the activity series, figure out which ones you're comparing. Like for the next one, it'll be magnesium and hydrogen sulfate, which is sulfuric acid. So you're going to be comparing hydrogen with magnesium, and figure out if a reaction is going to happen in each of these cases. And put them in the boxes. And check your work with the key in Schoology. The next reaction type is double replacement, and that's where two compounds react. The cations switch places, and they make two new compounds. It's also called a precipitation reaction because the product that's formed is usually a solid, which we call a precipitate. So the general equation is one compound AB reacts with a second compound CD, and the two cations, in this case A and C, are going to swap places. So you get C with B. They stay in their same order. It's still cation followed by anion, and then A makes a bond with D. So for example, sodium chloride reacts with lead nitrate. Sodium and lead swap, and you get sodium nitrate, which has, again, a different formula. There's only one nitrate. And lead chloride, which is PbCl2. So fix all the formulas. This one's actually not balanced. To balance this guy, we'd have to balance the nitrates by putting a 2 in front of the sodium and sodium nitrate. And then we have to put a 2 in front of the sodium in sodium chloride, and that would also balance the sodium and the chloride. So you definitely want to fix that in your notes. The products of a double replacement typically are solids, and that's if you form a compound that is insoluble. We call that a precipitation reaction. You can also form a liquid, and the liquid is always going to be water, and that's what happens when you mix an acid and a base. An acid gives the H, and the base gives the OH, which makes H2O, water, and that's what we call an acid-base or neutralization reaction. The last type of product that you can make is a gas, and that's if you do a double replacement and you make hydrogen carbonate, which is H2CO3, and this falls apart to give CO2 and water. So in order for a double replacement to have a reaction, it has to form a solid, a liquid, or a gas. But here's some, just for practice switching the cations and then balancing the equations. These ones are balanced. So lead nitrate, Ki, gives potassium nitrate and lead iodide. Barium chloride plus sulfuric acid, remember hydrogen acts like a metal, so it swaps like the cation, gives barium sulfate plus HCl, and it's balanced with a 2. Magnesium carbonate plus sulfuric acid gives magnesium sulfate plus H2CO3, which remember falls apart to make H2O plus CO2. And this one you do have to remember. And you can either write it in 2 steps like I have done here, or you can skip the middle step. You don't have to show the H2CO3. So how do you determine if a double replacement reaction is going to take place and make a solid? You have to use what are called solubility rules, and those are shown on the next page. And you don't have to memorize these, they are given, but you do have to know how to use them. And the way this table is organized is these ions are the ones that are soluble, and what soluble means is they are aqueous in solution. They don't form a solid with water. And there are some exceptions to a few of these. A lot of silver and lead compounds form solids because they're very heavy. And these are the anions that are insoluble, typically insoluble with water, except when they are with group 1 metals or ammonium ion. So for practice, shut off your video and go through and determine the solubility of these compounds and then turn it back on and check your work. The last type of reaction we're going to do is combustion, which is defined as reaction with oxygen. So the general equation is typically it's compounds with carbon that combust and react with oxygen and make CO2 and water. In fact, if carbon compounds undergo combustion, they always make CO2 and water, which makes the products really easy to predict. They can be a little bit tricky to balance though. What you want to do is first balance carbon, then balance the hydrogen, and then count up the oxygens on the right and do the oxygen last. If you get an odd number of oxygens on the right, then double everything up and go back and do it again. If it's carbon, it has always going to make CO2 and water. If you combust a metal, it forms the metal oxide, and we'll show an example of this. So these are shown and then balanced. Again, hydrocarbons react with oxygen to make CO2 and water, and practice balancing those. Be careful, if it's a sugar or something that has oxygen with carbon, then you have to subtract these out before you balance the oxygens. So 6 CO2s, 6 carbons, 6 waters, and then this is going to give us 18 oxygens. But don't forget that there are 6 here, so that's 12 left, so it's going to be 6 O2s. Here's a metal. So metals react with oxygen, and they make whatever the metal is, it makes the metal oxide. And notice that these are also labeled synthesis reactions, so some reactions can be categorized in more than one way. So for the next 3 pages, the work, I want you to work in your packet, and the keys are on Schoology, they're not in the video. So go through and do the work and then check your keys for the next 3 pages in your packet.